Hi there, welcome to Campus Interaction, the most preferred portal by colleges and companies. In this Java Get Industry Ready video tutorial, in this chapter we will see only about primitives. So what are primitives? Why do we need primitives? We'll also see about we'll also write few code using primitives. And we will also see a tip about primitives even a 5-year experienced Java developer may fail to answer. So what are primitives? It's basically used for calculation and to store numbers. This is very basic of Java. If you want to store numbers, which I'm sure you will at some point when you start writing Java code, you will use primitives. If you want to store characters like A, B, or Chinese characters, or Hindi character, Tamil character, you would use primitives, char. Or if you want to just have a on and off like true or a false value, then you would use boolean. So following are the primitive data types. You have byte, short, int, long, float, double, boolean, and char. You don't have to remember the values. It's good to remember some of the values like what byte stores, short, int. But long and float, all that the values are too big. So you just remember about 2 power 32, 2 power 64. Long would be the biggest, which is 2 power 64. Equivalent of long is double 2 power 64. So what's the difference between int and float and long and double? Int just store integer value. It doesn't store any decimal value. Float is used to store decimal value. Same with long. If you want to store more than 2 power 32, then you would use long. Let's say population of India. You would use long for that. But if you want to store a large number, which is larger than 2 power 32, and you want to store decimal value, then you would use double. Generally, for decimal value, you would use double. Don't go for float, because I'll explain you later on. But generally use double for decimal value. So let's go to the next point and start writing some program. I've already written some program. We have gone through about writing programs in our previous chapter. So to refresh your memory, go to your source packages, create a package called number examples. So all you have to do is source packages, right click, new Java package, and call it as number examples. I suggest you use the same name, because I'll be sharing this code, and also I'll be building on these code as we go along. So I don't want us to have any differences which you may find it difficult to consolidate. So first one is print numbers. It's fairly easy. The first exercise I've given myself is to print the numbers. In order to print the numbers, I just want to store 150.09. So it's fairly straightforward. So as I've said, 100 is less than 2 power 32. So you are going to use int for it. And to store double, to store 100.00, use double. So as I've given in my previous chapter, one of the tip I gave was don't type public static void main. It's an old way of doing things. If you want to work as an experienced programmer, type PSVM, just type tab on your keyboard. Then print double, and you know how to print values now, so just use system.out.println, and that's it. So I'll cancel that. I've just printed integer value. As I told before, use the shortcut SOUT and hit tab on you. Double value is, just put colon to make it pretty, D, and then how do you run and compile? Shift F6. So as you can see, these two are printed. Fairly straightforward, no confusion whatsoever. I'm sure everyone would have done that. Now let's go and see how to add two numbers. Again, it's fairly straightforward. All you have to do is define your integer, again define another integer, add these two together, print it. Fairly straightforward, absolutely no issues there. Now you know how to store integer, so you call it as int with a keyword, you name it I1 and you store a value against it, and you can also do that operation. Now let's see how you are going to store a large value. Let's say this is the value that you are storing, and let's add one more number to it. Let me type int I1 equal to, let's copy, I'm a bit lazy, so let's copy and paste it, 8. So what is the error it's giving? It says integer number is too large. As you can know, if you calculate it, 2 power 32 is actually equates to 2 power 32 minus 1 actually equates to this number. This is what you can store. This is the maximum you can store in an integer. So what do? You move on to the next level, which I've told you is long, which is 2 power 64. So if I change this to long, I can easily store this, but still I'm getting an integer number too large error. Why is that? That's because the compiler always takes this value as an integer. So when it tries to take this value as an integer and tries to store it, it thinks it's an integer and it says integer number too large. So how do you tell the compiler, sorry, I'm not storing the integer value, I'm storing in fact a long value? So all you have to do is at the end tell L. When you do that, the compiler knows it's a long, so it doesn't throw any compilation error. Remember that when you're going to store more than the allocated integer value, even though you store it, you still have to put L at the end. So when you want to store long, at the end of the number put L to tell the compiler. So all you have to do is again south my long value is type I1, or to be precise, let's call it as L, then type L. Again, to run this program, shift F6. So I've got the values now. Brilliant. So it's fairly easy. So if it's long, at the end put L. So store float. How do you store the float values? Again, I've got a public static void main. So float f equal to, let's say, 100.00. It's giving me an error. Why is that? It says you need to define it. It's very similar to long. At the end put f. But you don't have to do that for double, because Java by default take the double value. So 100.00. Fairly straightforward. South float is south double is print both values f d. Straightforward. Shift F6 should print you that. Absolutely no issues. Now you know about primitives. So for long put L at the end, for float put f at the end. Very simple. So we have written all this program. If you want, you can practice it again. So let's move on to some of the interview questions. So what are different Java primitives? I'm sure you know this now. Int, long, byte, short, double, long, float, character. So what is the maximum I can store in int? You know that now by 2 power 32. And if you have a good memory, you can also give that number. But 2 power 32 is good enough. So how do I store a decimal value? You just call it as double D equal to 100.00 or float F equal to 100.00 F at the end. What's the difference between int and long? I'm not even going to answer that. You should know by now. You should know that by now. What's the difference between float and double? Again, you know the answer. It's float is 2 power 32 and double is 2 power 64. Both are used to store decimal values. But here is the big question. This is the question many junior Java developers will fail to answer. Can I use float or decimal to store precision values like CGPA or salary? No, you can't. Because Java doesn't store the exact values for float or decimal. When we go into advanced Java, I'll explain why. But for now, remember, you can't use these two to store precise values. So it's actually double, my mistake. For that, you would use different values like big decimal. But for now, if you want to store decimal values, use double. Now here is the next big question. Even the 5 years experience can't answer this. Are all primitive thread safe? What do you mean by thread safe? So when we go into advanced Java about thread, I'll explain what thread safe is. But for now, remember, all primitives are thread safe except long and double in 32-bit Windows environment. In 64-bit Windows environment, all primitives, including long and double, are thread safe. But in a 32-bit environment, except for long and double, because it's 2 power 64, which is a 64-bit long, those are not thread safe. Anything which is 32-bit long or less than that are thread safe in Windows 32-bit environment or Windows 32-bit server. Remember that. I'll explain about thread safe and other details later on. Alright, thanks a lot. I'm trying to keep the tutorials as short as possible so you don't get bored, and also you will have time to catch up with the programs. Thanks a lot. See you soon. Bye.